Now we're live. Okay, we're good. Okay, so I think today's going to be pretty easy. So our objective is to talk about similar polygons and their ratios. Okay. Oh, it's Friday the 13th, you guys. Did you know that? I just realized that. Friday the 13th. Ah! Wow. So here's what we know about similar polygons. Two things. One, corresponding angles are equal. Okay. Corresponding angles are equal. And corresponding sides are proportional. That means same ratio, okay? Same ratio or scale, right? We talked about the scale or scale. Same ratio or same scale, okay? So example one. Oh, I might be going too fast. I'll wait for you to get caught up, okay? So here's what we're going to do. You guys ready for example one? Now this is important how we write this. So we're going to use this symbol. All by itself means similar. That not equal, but that symbol means similar, okay? We're not going to use an equal sign because they're not equal. These two triangles are not equal. One's bigger than the other, right? But they're similar. So when we say that triangle ISR is similar to triangle, we just got to match up the angles to the angles. So when I write over here, now wait for everybody to watch. It's really actually pretty easy to watch it. I am not going to write X, Y, Z. It's wrong. Why is that wrong?
Because it's not the same order.
Yeah, it's the order that's important. Does that make sense? Totally right, Scott. I got to write Z, Y, R, or Z, Y, X. So you're totally right, Scott. So I'm not going to write that at all. I've got to put the exact same order down. So I'm going to write it as, let's see, I goes to Z, right? And S goes to Y, and R goes to X. Okay, so down here, we're going to put ISR is similar to triangle ZYX. Okay, right? Does that make sense? So then we know that angle I is congruent or equal to angle Z. And you guys see this word congruent, but don't let that bother you. Equal, congruent, same thing for us. We know that angle S is equal or congruent to angle Y. We know that angle R is equal or congruent to angle X. Okay, does that make sense? So if I were to put numbers in here, I could. If I say that angle I is, say, 30 degrees, then angle Z's got to be 30 degrees, right? It's that easy. If I say angle Y is 70 degrees, then what do we know? If angle Y is 70 degrees, then what do we know? Yeah, angle S has to be 70 degrees. Now let's see, that's 100, which means angle R's got to be 80, right? Which means angle? Yeah, and I just made those numbers up. Okay, but, you know, that has to be true. Now, we also know this, that the sides are going to be proportional. I know that the 25 goes to 15 because IR goes to ZX. You guys agree with that? I also know the 30, this 30 goes to my 18 because IS matches up with ZX. So I've got my IR goes to my ZX as my IS goes to my ZY as my RS goes to my XY, right? So I'm putting the sides together. This side goes to this side. This side goes to this side. This guy's side goes to this side. So as my 20 goes to my 12. Now, okay, these should all be the same ratio. In fact, I'm going to highlight that again. These should all be the same ratio, so, or the same scale. So if I reduce all of these fractions, hopefully I'm going to get the same number, right? Well, 25/15 could reduce to 5/3. Okay, so this reduces to 5/3. 30/18. Let's see, I can divide both by 6, and if I divide by 6, I get 5/3. 20/12. Let's see, if I divide both by 10, I get, no, by 4. I'm going to get 5/3. So they're all the same ratio. So I'd say, what is the ratio? 5/3, right? What's the ratio? 5/3. The ratio is 5/3. Okay. So what's the ratio of similarity? 5/3. Thumbs up? It's not that hard, right? You guys agree? Okay, example 2. I've got two different things. Let's do this. We've got two different problems, okay? So let's do the first part, because the first part's really easy. So if they're similar, then, and I want to find x, I'm just going to match them up. I could say 15 goes to 18, and 20 goes to 24, and x goes to 30, right? So if I want to solve them, I can pick any of these. It doesn't really matter. I'm going to say, well, let's just go 15 goes to 18. 15 goes to 18 as x goes to 30. Right? 15 goes to 18 as x goes to 30. And let's solve. Well, if I'm going to solve for x, I'm going to undo x divided by 30, right? Let's undo it. Let's solve. How do I solve for x? Instead of x divided by 30, we'll just multiply by 30. Multiply both sides by 30. Use a calculator. Let's see. Calculator. Here's one way over here. Okay. Oh, I'm just going to multiply and divide, right? So we're just going to go, okay. I'm just going to go, okay, what is 30 times 15 divided by 18? I get an answer of 25. So the value of x is 25. Okay, thumbs up. Is that pretty easy? Okay.
Or could you just simplify the fraction and
Heck yes, Scott. Wouldn't that be easier?
yeah.
Heck yeah, I totally agree. All right. Now, second part is just as easy, okay? What goes to what, okay? So if I want to find x, it's up to you. What do you want? Well, I can see it. Can you guys see it? Do you see it's twice as big? I could say 12. How about just 12? I could do any of them. You guys are with me? I could do any of them. Do you see it's twice as big, though? So x has to be 10. But I could say, okay, 12 goes to 6 as x goes to 4, right? Or any of them, right? Any of the corresponding sides. I just picked that one. Any of them. I could have gone 16, 8, but I can see it's twice as big. Multiply by 4. Multiply by 4. I already know the answer, but I'm just going to do the math anyway. What's that? 48 divided by 6 is 8. X equals 8, okay? What do you think? Is this easy? Thumbs up? Okay, good. I got one thumb up. Think, Gretchen. You're the only one who's actually maybe awake in here, okay? Scott, I got a second thumbs up, okay? Now the perimeter. says find the perimeter of gazebo A. All right, so, well, let's see. First of all, let's find the perimeter of gazebo B. $15 plus 9, hold on, I'm going to do this. I'm going to go 15 plus 9 plus 12 plus 15 plus 18, right? And I get an answer of 69. So that equals 69, okay? Now, the two gazebos are similar. So what I'm going to do is find their ratio. What is their ratio? Okay, well, the ratio is 10 to 15, right? I got those two numbers. So the ratio is 10 to 15, which reduces to 2 to 5, okay? Or 2/3, okay? 2 to 3. Okay, there's my ratio. So the perimeter should have the same ratio. So I'm going to write this down. Yep. And I'm going to say, yes, Scott, you're totally right, okay? So I'm going to set it this way. I'm going to say that 2 to 3 is equal to A over 69. And Scott, you're right. Okay, so I went small to big. Okay, let me just write this down. Small, so you guys see it. Small to big equals small to big. I've got to set it up correctly. Scott, you're totally right what you said, okay? But some kids didn't see it, okay? But what I did is this. With ratios, and I don't know if you guys have done this in chemistry or in science yet, but I went, the 2 to 3 is the small side to the big side, so then I got to go small perimeter to big perimeter, and just solve for it. What you said was correct, Scott, if I multiply by 2/3. So I'm just going to multiply up by 69. So multiply by 69. Multiply by 69, which is 2/3 times 69, Scott, correct? So I'm going to go 69 times 2/3, and I get 46. Okay, so the perimeter is 46. Got it. Okay. And if I wanted to find all the other sides, I can because I've got the ratio, right? Now the area is different, and we learned about the area yesterday, right? So the ratio is twice as big, right? ABC is twice as big. Is this going to be half as big? It's going to be a fourth as big. Remember that yesterday? It's not going to be half as big. It's going to be 1/4 as big. So I do know that this triangle here is twice. The ratio is twice, okay? The ratio is 2 to 1 from here to here. Or, since we're going from big to small, or it's going to be 1/2. Now the ratio is 1/2 for this scale, but the area has to be different. The area is going to be actually 1/4 because, watch this, if I square it, because 2 dimensions, I'm squaring my scale. I square it because it's 2-dimensional, 2D, because we changed the length and the width. I'll say it again, change the length and the width, so we changed it twice. So my scale then becomes really a 1/4 scale. So that's my area scale. So then if I take my 1/4 of 36, I get 9 centimeters squared. Got it?
Where'd you get 36?
It was given to me in the problem. Yeah, great question. Okay, that's all I have. What do you think? Pretty easy? And I have a worksheet that we're going to do for homework, and then if you're not done with your tessellation, you get plenty of time to get it done, and it's Friday. Stop recording.